All right, ladies and gentlemen, today we are looking at lesson 1.2, day 2, solve multi-step equations. And before we get to the actual solving part, I want to remind you how to do some of those multi-steps at the very beginning. And essentially, it's kind of like this, combining like terms. What I tried teaching my students in 7th grade, maybe your teacher did as well, is to go ahead and look for same variable, same exponents. Now, sometimes I ask my students to do the boxing and circling. It's just an easy way to identify like terms. I'm going to include my signs here. Now, obviously, the subtract 1 is not considered part of the x's, so I can use a separate shape, or technically I could have left it alone. So in combining it, 5x plus 2x is simply 7x, and then I've got a subtract 1. Now remember, there's nothing else that I can do there. I cannot say it's 6x because the 1 does not have a variable. So technically, it has currently been simplified. Now this is an expression, not an equation. We'll get to the equations in just a moment. Just a little bit more combining like terms practice. So this one, they have the same variable, but they do not have the same exponents. So if I were to do the shapes again, I can do boxes, circles, triangles, horseshoes, fish. I've seen students do fishes before. Notice how I have the subtraction sign included with the 3x squared. And again, the last one is different, so I can circle it, leave it alone, triangle, whatever I like. So combining my like terms, 7x squared, subtract 3x squared, a basic 4x squared. And then the negative 2x just kind of tags along, like that annoying sibling that you might have wants to always tag along, do what you're doing. But again, cannot combine them. Even though they have the same variable, they do not have the same exponent, so leave it alone. Some of your problems will require your distributive property. The 7th grade students already are working on this. You should have distributive property mastered. The way that I ask my students to do it, though, is to show this little arrow. The little arrow is an acknowledgement that you are going to multiply those two values. So 3 and 2 is going to give you a nice 6. And then you're also going to do 3 multiplied by negative x. If you want to put a little 1 there, you can, not required. 3 multiplied by negative 1x is a negative 3x. And then, of course, you have the plus 4x stays the same. Do not distribute the 3 to the 4x. All right, now that I have cleaned it up, started my simplification process, again, I'm looking for my like terms to combine. So I've got my negative 3x and my positive 4x. I always do the variables before the integers. Again, the integer is just a positive 6. A negative 3x plus a 4x gives me a 1x, but since you're getting ready for high school, please write it as a simple x. When you're simplifying, your answer should have no hidden ones. Your work can, though. Like up here, I wrote 1x, but that's part of my work. My answer is simply an x and a positive 6, so I put a plus 6. Nothing else I can do, so I stop there. On this one, if you'd like to, you may put a negative 1 as a little bit more visible, so that when you do your distributive property, it's a little bit easier for some students. So I've got negative 1 times 2x, which is negative 2x. Again, just practicing my distributive property, then combining like terms. Negative 1 times negative 5 is a positive 5. And then a simple plus 7. So if you notice this time, my variables, they are not the like terms. So if I do a box on the negative 2x, there's nothing else that can be boxed. So I go to the circles or triangles, whatever you'd like. Make sure you're getting your signs as well. So my simplified answer for this expression would be negative 2x, and then a positive 5 and positive 7 gives me a positive 12. Excellent. All right, on this one right here, again, same idea. Go ahead and put a little 1 if you'd like to. Now, let me show you what not to do, because this happens quite often for my students. They see this as, oh, 9 subtract 1, so they put an 8 there, and then they proceed to use their distributive property. That is not allowed. My order of operations tells me that I am supposed to multiply before I subtract. So with that proper thinking, the 9 stays the same, and then I distribute the negative 1. Negative 1 times 8x is negative 8x. Negative 1 times positive 2y gives me negative 2y. Now, if you notice here, there's nothing that I can really combine. There are no like terms for the x's, the y's, or even the basic integer. So my preferred answer would be written like this. The x part, then the y part, then the integer part. A constant, if you will, because there's no variable there. So again, the letters are alphabetical order, and then the integer all by itself just goes at the end. All right, now we are ready to start solving. So you may have seen problems like this before. If not, it looks like a really complicated fraction, but it's really not that bad because we'd like it to look like a two-step problem. So our whole goal is to try and get it simplified as best as we can to be a two-step problem. So if I were to get rid of this 5 somehow, I would have it as 2s plus 3 equals a number. So if I were to get rid of the 5 by multiplying, not by the reciprocal, so don't say the reciprocal, just simply by 5 over 1 on both sides, then I would be able to write it as 2s plus 3. Now the reason I can do that is because these 5's cross cancel. If I did the reciprocal, that means 2s plus 3 would also be at the bottom. That's why I did not say the reciprocal, just 5 over 1. And now it's equal to 30. So if you notice, again, we've got a nice two-step problem. We'll go ahead and complete it. So we're going to subtract 3 on both sides. So it means I have 2s is equal to 27. Divide by 2. So s is equal to, and we are going to keep it as an improper fraction, 27 over 2. Because if I were to check it again, it would be 2 multiplied by 27 over 2 plus 3 divided by 5, and I should be able to get a 6. So the little 2's cross cancel. So it's really just 27 plus 3, which is 30 divided by 5. And we're trying to see if that equals to 6, and of course it does. So when I check it, I substitute. I've got a line of work, and then I got the comparison. 6 does equal 6, so I'm good to go. All right, on this run right here, we're just going to go ahead and practice our combining like terms. So if you notice, 15y is all by itself, but my positive 21 and my positive 10 are good to go. So my new problem is 15y plus 31 is equal to 61. So again, we simplified it to a nice two-step equation, and that's our whole goal. Because if we can get it to a two-step, we should be able to solve it. So I've got 15y is equal to 30, and then just divide. Since y is equal to 2, I can come back up here in my check. So that would be 15 times 2 plus 21 plus 10 is equal to 61. So that's just 30 plus, and again, we already know that's 31. So yeah, 61 equals 61. Now again, you may be thinking, do I really have to do the check? It is to go ahead and do a nice test-taking strategy. Ooh, this is looking like a good one here. Got just a few more. So on this one here, I'm going to have to do pretty much all of the work. Distributive property, combine like terms, and then solve my equation. So let's see here, one step at a time. 5 times 1, 5. 5 times negative 2w, negative 10w. Plus 8w equals 15. Combining like terms, negative 10w, I like saying w, plus 8w, and the 5 stays the same. So negative 10 plus 8 is going to give me a negative 2w. Positive 5 stays the same, equals 15. Subtract 5 both sides. Negative 2w is equal to 10. Quick division. Again, a lot of little mistakes that you can have with your negative signs. So you got to be really careful. So let's check to see if I got it correct. So when we check, remember we check with the original problem. So it really means 5 times 1 subtract 2 times, and again, w is negative 5. And then plus 8 times w is negative 5, 15. All right, so trying to clean this up here. I'm going to keep the 5 the same. And this is really 1, and then negative 2 times negative 5 is 10, right? So it's really meaning 1 plus 10, which is 11. And then if you want to multiply this one right here, you can, which is going to be negative 40. So this one being a much more complicated problem, I might have to show a little bit more work on my check. So it's 55 subtract 40. Does that give me 15? Yes, it does. 15 equals 15. Very nice. In other words, if I had a 5, it would not work. Because that would give me a negative 10, that would give me a positive 40, it would give me some weird answer, would not give me a positive 15 for my comparison. All right, let's see here. Remember, we can go ahead and put this here. Now remember, if you need to, you can pause the video and write down the problem if it feels like I'm going fast. Negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. Negative 1 times 2 is negative 2. Negative 1 times negative 2x is positive 2x. And equals to 10/3. So let's combine our like terms. I've got my x's to combine and my integers to combine. All right, for my x's, I've got a negative 4x and a positive 2x. That means I'm going to have a negative 2x. Because they're different signs, so I subtract and take the sign from the greatest absolute value. Negative 4 and negative 2 gives me negative 6. All right, looks like a nice two-step problem, except for that fraction on the side, but we're going to do our best that we can. So I'm going to add 6 both sides. So that's going to give me a negative 2x is equal to, now remember, in order to add this, I need to go ahead and, you know what, let's change this to a simple denominator of 3. How does a 6 over 1 change into a denominator of 3? Yeah, we just multiply by 3. 6 times 3 is 18. So if I add those together, since they're nice positives, that's going to give me a 28 over 3. Now, since this is a fraction over here, I'd actually like to go ahead and put this as a fraction as well. So that means I can go ahead and multiply by the reciprocal, and maybe I can actually cross cancel. So negative 2 over 1, the reciprocal is negative 1 over 2. So x is going to be equal to a negative, of course. I'm going to go ahead and cross cancel. 2 becomes a 1, 28 becomes a 14. So that's going to give me a negative 14 over 3. Now that check is obviously going to be a lot more complicated. If we have time, we will do that. So let me move on to the last example, and if I have time, I'll come back to help you on the check for 22. All right, what we have here is a problem that is going to require us to know this information here. The great thing is it's already given to us. Later on in chapter 3, I think it is, you're going to have to know that on your own. So it says, find the value of x if the sum of all the angles, so it means I'm going to add up all my angles, is 540. The two angles are, so do you see the arrows, 4x plus 6. So when I write it out, I'm going to say, okay, just work clockwise, if you will. I'm going to say 4x plus 6, so that's this two angles here, plus 113. Don't forget the little box. We should know the box is a 90. And then we've got a 5x. And my sum, again, addition, is 540. So I want to simplify it into a nice two-step problem. So I'm going to go ahead and mark it up here. So combining my like terms, I get a 9x plus a value, and that's equal to 540. Now, if you need to find that value, you could just bring up your calculator or your phone. If you can't do it in your head, you just type in 6 plus 113 plus, and don't forget the 90. That's a common mistake there. So I've got a 209. So I got a nice two-step problem. So I'm going to go ahead and subtract 209 from both sides. So again, we're still showing work on our paper, but if you have to use your calculator for 540, subtract 209, just speeds it up a little bit. We've got 331. Divide by 9. Again, we're showing our work. X is equal to, it's already on your calculator, just hit divide by 9, equal sign. Something might be wrong. You know what? I think they're saying here that this is, each one is 4x plus 6. Aha! So let me do a small edit. Sorry about that. And that's the interesting thing, is when you're doing it and it doesn't come out right, you can go back and look at it. So 4x, I think this is going to be good. So let's box that and circle that. So I've got 4x plus 5x, which is really 13x. Yeah, I got a good feeling about this one. And again, that's why we use pencil. So we got 6 plus 113 plus 90 equals 215. Subtract 215. $13x is equal to, so I do 540, subtract 215. 325. Divide by 13. Got a good feeling about this. Divide by 13. Yeah, so it gives me a nice quote-unquote normal answer, not a decimal answer. So that means the value of x is 25. So if I wanted to, later on, I would ask you, well, what's this angle measurement here? If it says 5x, well, how many degrees is it? If each one is 4x plus 6, well, how much is each one really equal to? Remember, they're the same. X is 25. We're going to practice that later on. All right, nice. And we're going to go ahead and call it there. Got to get ready for class. Be amazing.